Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to continue with work pressure or pressure volume work. I'm going to go over two practice problems where I'm going to use the equation to help me find the work given a certain situation. So in the first problem, we're going to deal with inflating a balloon. So in this case, a balloon is being inflated. You're changing the volume against an external pressure, and you want to find the amount of work done. So in this particular problem, you start off with an initial volume of the balloon at 0.100 liters. You get a final volume of 1.85 liters. You have an external pressure of 0.110 or 1.00 atmospheres, and you're trying to find the amount of work done or done by the gas in joules. And so in order to do that, we have to use this conversion of 101.3 joules is equal to 1 liter per atmosphere. Okay. So we go back to our equation that we have, and that is work is going to be equal to the external pressure multiplied by the change in volume. And remember, volume is the change in volume. The change in volume is final volume minus initial volume. So it's going to have the external pressure multiplied by final volume minus initial volume. So we know the external pressure, we know the final volume and the initial volume, so we just plug everything in. So we have 1.00 atmospheres. The final volume is 1.85 liters minus the initial volume, which is 0.100 liters. So we got to subtract, and so here we need to pay attention to the least number of decimal places. So when we subtract these two, we get 100 atmospheres again for our external pressure, but then 1.85 liters minus 0.100 liters is going to be 1.75 liters. Okay, and notice that I went from 3 and then 2. The answer should be in two decimal places because the least number is 2 because I am subtracting. So remember, because you're subtracting or adding, you're looking at the least number of decimal places. So the least number of decimal places is here. And so now now I multiply these together. 1 times anything is 1, but I have to pay attention to sig figs. So I have 3 sig figs, 3 sig figs. So my answer is in 3 sig figs, 1.75 liter atmospheres. So that is the answer to this particular problem. However, I have to remember that they want the answer in joules. So now I can use this conversion factor, 101.3 joules is equal to 1 liter atmospheres. So then I can convert this. So I can have 1 liter atmosphere on the bottom, and then I can have 101.3 joules on top. So liter atmospheres cancels out, and now I can multiply that on my calculator. And again, I have 3 sig figs here, I have 4 here, so the least number is 3, so that my final answer should be in 3 sig figs. So 1.75 times 101.3 equals, and I get 177.275 joules. And so again, I'm keeping 3 sig figs, 1, 2, 3. So I keep the 177 joules. And so that would be the amount of work in joules done by the system. And oh, I can't forget my negative. So there's a negative here. So this was positive, so this should be negative as well. So this is negative, negative, negative. So this is important because the negative sign tells us that work was done by the system on the surroundings. So the system lost energy in the form of work. Now, one thing I want to point out, which I think is very interesting, and you may have wondered about this, is when we have our R value for the gas laws, right, or some R values when you're dealing with energy, the R value is for the ideal gas law is 0.08206, and that's liter atmospheres over Kelvin mole, right? But then when you're dealing with energy, like when we're, if you are dealing with energy considerations, like the average kinetic energy of a gas, or anything like that, or you're looking at the root mean squared velocity equation, you also have the R value, but it's a different number, right? And the units are different, so it has a different number. I think it's something like 8.134 or something like that. But then if you look at the units, the units are in joules per Kelvin mole. And so you may have wondered about this, like going from joules to liter atmospheres. How is that possible? Where does that change come from? Well, you can see here that it changes because of this relationship. So you can convert liter atmospheres to joules using this relationship. So that's part of the reason why this becomes a different number. So if you took this and you multiplied it by this, you would get a number like that. So that's, I thought, something very interesting. So this is related to each other through this. Okay, and then the liter atmospheres, how can that be related to energy? Well, you can see that it's related to energy through work, right? Through work done by a gas, right? So you have external pressure, which is in atmospheres, multiplied by volume, which could be in liters. You multiply those together, you get liter atmospheres. So you can see that relationship being there through work. Okay. So the next problem. Next problem is where you have fuel burned and you have a piston. So this is like your combustion engine. So you've got fuel being burned in the engine, it ignites, produces a gas or explosion, and the piston moves because of the pressure due to the expansion of the gas. So, or of the reaction. So here's the information we're given. The piston was initially at a volume of 0.255 liters. It goes up to 1.45 liters. The external pressure is 1.02 atmospheres. And they gave us, in addition to that, an amount of heat that was emitted by the reaction itself. So 875 joules is emitted as heat. So they're giving us heat, and they want the change of internal energy. So we got to go back to our equation for the change in internal energy. And so remember, the change in internal energy is equal to work plus heat, right? So in this problem, there was no heat involved, so Q was 0. So our internal energy was all about work due to pressure and volume change. Here we're going to have to do calculate work. So here the internal energy is going to be equal to the pressure, the external pressure, multiplied by the change in volume, final minus initial, plus the heat that we got. So we gotta plug in what we know. So that was 1.02 is the external pressure. Okay, so we're gonna put in 1.02 atmospheres. We have the final volume, which is 1.45 liters. We have the initial volume, which is 0.255 liters. And then we're going to add Q. Now, Q here is negative because we're emitting heat. We're losing heat from the system. So we're losing energy from the system. So that's going to be negative. So that's going to be a negative 875 joules. Okay, so here we're going to use our calculator to calculate this. So we have 1.02 times, we're going to have 1.45 minus 0.255 equals, and we get here, we're going to get 1.2189 liter atmospheres, right? And we're going to subtract from that 875 joules. Now, we have to convert liter atmospheres to joules if we're going to subtract these or add these together. So we need to change 1.2189 liter atmospheres over 1. We're going to use, again, we're going to use our 101.3 joules to 1 liter atmosphere. So 1 liter atmosphere on the bottom, 101.3 joules on top. Liter atmospheres cancels out. And we're going to multiply by 101.3 times. And so, of course, we get 123.4745. We'll stop there, joules. And again, we're going to subtract from that 875 joules. So if we subtract, now before we do this, we need to keep track of our sig figs. So here I have, where are we? So, let's see. Okay, so here we subtracted, so we're looking at decimal places. So our answer should be in 2 decimal places. So that means we have 3 sig figs here, 3 sig figs here. So our answer here is in 3 sig figs. So the last sig fig is there. And then when we subtract, or here we multiplied. So when we multiplied, we have 3 sig figs here, and we have, so this is 3 sig figs, this is 4. So this should be in 3 sig figs, okay? So then when we subtract, it's the number of decimal places, which is both 0. So we're going to subtract 875 equals, and we get a negative 751.5, which when we round to the proper number of sig figs is going to be negative 752 joules. So that is the answer. So I hope this was helpful. If you like this video, share this video, hit the notification bell for be notified of other videos. Subscribe to the channel, make a comment in the comment section, and let me know what what you think. How do you like this video? What would you like me to go over? Thanks for joining me, and I'll see you next time.